This video is going to focus on how we form ionic equations, and I'm using neutralization reactions as an example for this. So this first one here is hydrochloric acid and sodium hydroxide. So this is an acid alkali, so we make a salt. So the salt in this case would be sodium, and then because it's hydrochloric acid, it would be sodium chloride. And sodium chloride is NaCl, and we always make water during neutralization, which is H2O. What we're going to do now is I'm going to assign charges to any of these substances that should have a charge. So for example, hydrochloric acid has got hydrogen ions and chloride ions. Sodium hydroxide has got sodium ions, Na+, hydroxide ions are OH-. Sodium chloride is sodium ions, which are positive, and chloride ions, which are negative. Now, water is a covalent substance, and that doesn't have a charge. Now what I'm going to do is look at the formulas, and I'm going to see which of these formulas have not changed from the reactant side to the product side. So for example, I've got Cl- here, and I've got Cl- here. So it looks like that chloride ion hasn't changed. So I'm going to put a cross through it, and we're going to ignore it. Same for sodium. Sodium is Na+ and Na+. My hydrogen and my hydroxide ions have changed because they're ions here, but here they've formed a covalent substance. So they don't have charge, and therefore they have changed. So what's left in my equation? I have got H+, I have got OH-, and then this side I've got just H2O. So that is the ionic equation for that reaction. To give you another example, here we have got calcium carbonate reacting with sulfuric acid. Again, it's neutralization. So I'm going to make a salt, which will be calcium sulfate. I will also get water, and because this is a carbonate, I will also produce carbon dioxide gas. So in terms of balancing this equation, calcium sulfate is that formula, water is H2O, and carbon dioxide is CO2. Let's assign the charges again. So calcium ions are 2+, and carbonate ions are 2-. Hydrogen ions are positive, and sulfate ions are 2-. Calcium, we've already said, is 2+, sulfate is 2-. Again here, water and carbon dioxide, they're both covalent, so they have no charge at all. So they're going to just be left without charge. Let's check, where are my spectator ions? Remember, that means the ions that haven't changed. So here I've got a calcium and a calcium there, so that hasn't changed. I've got a sulfate ion and a sulfate ion there, so that hasn't changed. My carbonate ion over here has changed into carbon dioxide, so I'm going to leave that because that is different, and I'm leaving my hydrogen ion because that's formed water on this side. So if I now write down what I have got left, I have got left a CO3 2-, plus I've got here, I'm going to change, I'm going to put 2 lots of H+ ions, and then I have got over here none of the calcium sulfate left, but I do have water and I do have carbon dioxide. So that is my ionic equation for that reaction. All we do is remove spectator ions, and they are ions whose charge hasn't changed during the reaction.